Acid rain is a term used to describe any form of precipitation, such as rain, snow, or fog, that contains higher levels of acidic components, primarily sulfuric and nitric acids. Unlike normal rain, which is slightly acidic, acid rain has a much lower pH, making it harmful to the environment. This phenomenon was first identified in the mid-19th century, but it became a major environmental concern in the late 20th century as industrialization increased. In this video, we'll explore what acid rain is, how it forms, its impact on nature and society, and what can be done to reduce its effects. Let's start by understanding the basics of acid rain. Acid rain forms when pollutants like sulfur dioxide, SO2, and nitrogen oxides NOx are released into the atmosphere. These chemicals react with water vapor, oxygen, and other substances to form sulfuric and nitric acids. When these acids mix with cloud moisture, they fall to the ground as acid rain. This process can occur naturally, but human activities such as burning fossil fuels have greatly increased the amount of these pollutants in the air. Understanding the chemistry behind acid rain helps us see why it's such a widespread problem. Main sources of acid rain are human activities, especially the burning of fossil fuels like coal, oil, and natural gas. Power plants, factories, and vehicles emit large amounts of sulfur dioxide and nitrogen oxides into the atmosphere. Natural sources such as volcanoes and wildfires also contribute, but their impact is much smaller compared to industrial emissions. By identifying these sources, we can better understand how acid rain is linked to modern lifestyles and energy consumption. Acid rain doesn't just affect the area where pollutants are released. Winds can carry sulfur dioxide and nitrogen oxides hundreds or even thousands of miles from their source. This means that acid rain can be a problem in regions far from industrial centers. For example, pollutants from one country can cause acid rain in another, making it a global issue that requires international cooperation. Understanding how acid rain travels helps explain why its effects are so widespread. Acidity of rain is measured using the pH scale, which ranges from 0 to 14. Pure water has a neutral pH of 7, while normal rain is slightly acidic, around 5.6. Acid rain, however, can have a pH as low as 4 or even lower. This increased acidity can have harmful effects on plants, animals, and even buildings. Monitoring the pH of precipitation is an important way scientists track the severity of acid rain in different regions. Acid rain can have devastating effects on forests. It damages leaves, weakens trees, and makes them more vulnerable to disease, pests, and harsh weather. The soil in affected forests can also lose important nutrients, making it harder for plants to grow. Over time, entire ecosystems can be disrupted, leading to a decline in biodiversity. Forests in North America and Europe have been particularly hard hit by acid rain, but the problem is global. Acid rain can lower the pH of lakes and rivers, making the water too acidic for many aquatic species to survive. Fish, frogs, and other organisms may die off, leading to a collapse in the food chain. Some lakes have become so acidic that they can no longer support life. The effects are not always immediately visible, but over time, acid rain can turn vibrant ecosystems into lifeless bodies of water. Acid rain doesn't just affect plants and water, it also changes the chemistry of the soil. Essential nutrients like calcium and magnesium are washed away, while toxic metals such as aluminum are released. This makes it harder for crops and wild plants to grow, reducing agricultural productivity and harming natural habitats. Soil degradation from acid rain is a slow process, but its effects can last for decades. Wildlife is also affected by acid rain. Animals that depend on forests, lakes, and rivers for food and shelter can suffer when these habitats are damaged. Birds may have trouble finding insects or fish to eat, while mammals may lose their homes as trees die off. The decline in biodiversity caused by acid rain can have ripple effects throughout entire ecosystems, making it harder for wildlife populations to recover. Acid rain doesn't just harm nature, it can also damage buildings and monuments. The acids in the rain react with materials like limestone, marble, and concrete, causing them to erode over time. Historic structures and statues are especially vulnerable, as the damage can be difficult or impossible to repair. This not only leads to costly repairs but also threatens our cultural heritage. While acid rain itself doesn't pose a direct health risk to humans, the pollutants that cause it, sulfur dioxide and nitrogen oxides, can lead to respiratory problems. These pollutants contribute to the formation of fine particulate matter in ground-level ozone, which can aggravate asthma, bronchitis, and other lung conditions. Reducing acid rain can therefore have important benefits for public health. Economic costs of acid rain are significant. Damage to crops, forests, fisheries, and buildings can add up to billions of dollars each year. Industries like agriculture, forestry, and tourism can suffer losses, while governments and property owners face expensive repairs. Investing in pollution control measures can help reduce these costs in the long run. Farmers are particularly vulnerable to acid rain, as it can reduce soil fertility and crop yields. Acid rain can also damage farm equipment and infrastructure, leading to higher costs for maintenance and repairs. In some regions, farmers have had to change their practices or switch to more acid-resistant crops to cope with the effects of acid rain. Acid rain is a global problem, but some regions are more affected than others. Industrialized areas in North America, Europe, and Asia have experienced the most severe impacts. In these regions, efforts to reduce emissions have helped, but acid rain remains a concern, especially in rapidly developing countries where pollution controls may be weaker. Because acid rain can travel across borders, international cooperation is essential. Treaties and agreements such as the 1979 Convention on Long-Range Transboundary Air Pollution have helped countries work together to reduce emissions. These efforts show that global environmental problems require global solutions. Governments have introduced regulations to limit the emissions of sulfur dioxide and nitrogen oxides. For example, the Clean Air Act in the United States set strict limits on power plant emissions. Similar policies in Europe and other regions have led to significant reductions in acid rain. These regulations show that policy can make a real difference in protecting the environment. Technology plays a key role in reducing acid rain. Scrubbers installed in power plants can remove sulfur dioxide from exhaust gases before they are released into the atmosphere. Advances in vehicle emissions technology have also helped cut nitrogen oxide pollution. Continued innovation is essential for further progress. Switching to renewable energy sources like wind, solar, and hydroelectric power can greatly reduce the pollutants that cause acid rain. Unlike fossil fuels, renewables produce little or no sulfur dioxide or nitrogen oxides. Investing in clean energy is one of the most effective ways to combat acid rain and protect the environment for future generations. Raising public awareness about acid rain is crucial for driving change. Educational campaigns, school programs, and media coverage can help people understand the causes and effects of acid rain. When the public is informed, there is greater support for policies and actions that protect the environment. Restoring ecosystems damaged by acid rain is a challenging but important task. Scientists use techniques like adding lime to lakes and soils to neutralize acidity and help plants and animals recover. While restoration can be expensive and time-consuming, it's essential for bringing life back to affected areas. Scientists monitor acid rain by collecting and analyzing samples of precipitation. They measure pH levels and track changes over time to assess the effectiveness of pollution controls. Monitoring networks around the world provide valuable data that guide policy decisions and help protect the environment. Individuals can also help reduce acid rain by conserving energy, using public transport, and supporting clean energy. Small actions like turning off lights or choosing energy-efficient appliances can add up to make a big difference. Everyone has a role to play in protecting the environment from acid rain. There have been many success stories in the fight against acid rain. In North America and Europe, stricter regulations and cleaner technologies have led to significant reductions in acid rain. Lakes and forests that were once dying are now recovering, showing that progress is possible when people work together. Despite progress, challenges remain. Some regions still struggle with high levels of acid rain, especially where pollution controls are weak or enforcement is lacking. Climate change may also interact with acid rain in complex ways, making it important to stay vigilant and continue improving our efforts. Looking ahead, future solutions to acid rain will likely involve a mix of technology, policy, and public engagement. Continued investment in clean energy, stricter regulations, and global cooperation will be key. By working together, we can ensure a healthier environment for generations to come. Acid rain has appeared in books, movies, and news reports as a symbol of environmental harm. These portrayals have helped raise awareness and inspire action. By understanding how acid rain is represented in culture, we can see its impact on public attitudes and policy. Ongoing scientific research is essential for understanding acid rain and finding new solutions. Scientists study the sources, effects, and ways to mitigate acid rain using advanced tools and methods. Their work provides the foundation for effective policies and technologies. Young people are playing an increasingly important role in environmental protection, including the fight against acid rain. Through school projects, activism, and community initiatives, youth are raising awareness and pushing for change. Their energy and creativity are vital for building a sustainable future. Acid rain and climate change are closely linked, as both are driven by the burning of fossil fuels. Efforts to reduce greenhouse gas emissions can also help lower acid rain. Addressing both issues together is essential for protecting the planet's health. In summary, acid rain is a serious environmental problem caused mainly by human activities. It harms forests, lakes, wildlife, buildings, and even human health. The good news is that solutions exist, from cleaner energy to international cooperation. By staying informed and taking action, we can all help reduce acid rain and protect the environment for future generations.